Okay, so this is the floating leaf disc assay, also known as the FLDA assay, or FLDA lab, for investigating the effect of light intensity on photosynthesis. The materials for this are pretty easy. You need some sodium bicarbonate, which is baking soda, a balance, of course, because you're going to be making a solution, weigh dish and spatula to make the solution, some liquid soap, a plastic syringe that's 10 cc's or larger, distilled water. You need to have a chloroplast source, so we are using spinach leaves, and a hole puncher in order to turn those leaves into discs, stir rod, pipette, beaker, plastic cups, a ruler or a meter stick, because we are going to be testing the effect of light intensity by varying the distance of these chloroplasts, aka spinach leaf discs, floating leaf discs, from the light source. And we need a light, so we're using flood lamps. And this lab also includes a second part where lab students groups investigate an additional variable other than light intensity. For all intents and purposes, this demonstration is just going to show the straightforward light intensity as the variable. So if we look over here, what we have in these cups, we have some spinach leaves that have been cut out using a hole puncher. They're in uniform discs. Each cup is in a solution of sodium bicarbonate with some dish detergent, measured to about 300 mils as the lab calls for. 10 discs in every cup. Every cup has been controlled with the exception of the control. I'll show you that one in a minute. This is not a control. This is a test cup. The control does not have any sodium bicarbonate that has been infiltrated into the discs. The cup is set up the same, but the discs have been treated differently. These discs have been vacuum infiltrated with a carbon source using the baking soda, the sodium bicarbonate. That's what the 10 cc syringe is for. And after we've infiltrated the discs to make them carbon heavy so that they sink, as we can see here, we put them into these 300 ml sodium bicarbonate and soap solution cups, and we are setting them underneath light sources, flood lamps that are set at different size, at different heights. So here, this is the test for 50 centimeters. We've started a timer about 5 minutes ago. The lab runs for up to 14 minutes, and it calls for us to start counting and measuring the time at which discs start to raise, which indicates rate of photosynthesis. So if you're looking at the rim right here, we've got that cup right there set at 50 centimeters going down the lab bench. That one is set with a more intense distance, so that's 100 centimeters. And then almost from ceiling to floor with that cup down there, that's 200 centimeters. These have been measured, and again, we are watching a clock, and we are going to be recording the time at which these chloroplasts, or these spinach leaf discs, start to raise. So here we already have, this one is at 30 centimeters. And we have 1, 2, 3, 4. This is at about minute, probably 5. And the lab asks us to stop once we have half of the discs in each cup that have floated. So at minute 5, we almost have the 30 centimeter completed. This is the 3 centimeter. And the 3 centimeter has 1 that is raised, 2, 3 that are on their way up. We're going to call this soon. We're going to just take this out. This is very close to the light source, as we can see. And we have many that have raised here. Once that's at 5, we've got number 4 coming up the side right here. We'll stop that and record the time. And over here, we are running a control. So the control is set at the most intense light, which is 3 centimeters. But these discs have not been infiltrated with a carbon source. So there's no carbon that's been introduced to these chloroplasts. So we will see what happens with these ones. So what we're going to do for the rest of the lab is walk around and just kind of keep time and mark the time that we have at least 5 discs in the cup that have raised. That's 50% photosynthesizing, and that is our benchmark.